So this is collab. So this is the first interface. If you are starting with a new notebook, click on new notebook. If you have one you want to upload, click on upload. I have my own on Google Drive, which is day 4. So I'll be starting from that. The last thing we talked about yesterday was logic. So I did a kind of small research on logic. I just want to show us what I found out. So logic, we have basically used logic to combine 2 or more conditions. We use logic to combine 2 or more conditions, and there are like 3 different kind of 3 keywords we can combine with logic. We have and. We can combine with logical operator. We have and, or, and the last one is not. For we to, if we want to have a true output, like a true condition, in a true output in our condition, it means all the conditions. Let me just show you the screenshots from one of the instructors at Ustaki. Can you see this?
Yes.
Hello.
Yes, we can see.
So we have PQ.
Yes,
Then
we
we have
can see it.
these are the 3 keywords, and or not. We have the P, the Q. These are just like conditions. Then you have true, true, false, false. For if you are dealing with and, for it to be truth, the 2 condition must be true. So we have true and true. Then we have true and false. One of them, the 2 of them are not true. We have false. False and true. We have false. False and false. We have false. But for or, it only needs one of the 2 conditions, one of the many conditions to be true. True or true is true. True or false is true. False or true is true, because for those 3 above, one of the condition is what is true. But for the last one, false or false, we have false here. Do we get that?
Yes.
Yes, sir.
The not operator is just like the inverse
Yes,
of
sir.
the not operator is like the inverse of the original condition. For example, not true, not P, our P is true. Not true, definitely something that is not true is false. Something that is not true is false. Something that is not false is true. The same thing for the last one. Then we have not P or Q. So the one in the bracket will first be taken care of. P or Q is what's true. Then not true will be false. Not true will be false. Not true will be false. Then not false will be true. That's basically the logic behind the logical operators. I think it should be a bit clearer now. The person that asked the question yesterday, I don't know if he's on the call. Do we get something from that?
Yes.
So today we'll be starting with this Python. Yesterday, let me check what we did yesterday. Yesterday we talked about variable string concatenation on day 3. So today we'll be talking about Python list. My list is equals to. We use this square bracket to denote a list in Python. We use the square bracket. We have different kind of brackets in Python. This square brackets, this is the normal parenthesis, and the third one is the curly bracket. As I've said yesterday, this curly bracket is used in Java. It's a type of programming language. So my list, a list is like a collection of items, and it can contain element of different types. For example, we can have integer, we can have string, we can have boolean, we can have float in a single list. For example, let's say 2, 3, 5, then 34.5, then 78, then bag. And I have false. So this is a list. That's my list. To check each element of a list, let's just print out. Let's see the element of the list. My list. This is what I have in my list: 2, 3, 5, 3.4. Then I want to check the first element, just like it's just normal indexing in Python, starting from 0. We know that already. That's how to access the first element. Then the last element, my list, then -1. I can slice my list as well. Slice means I need elements of range. Let's say I need from this to this. This is 0, 0, 1, 2. Then I'm starting from 3, 4, 5. Since I want this 5 to be included, I will put 6. That will be 3 to 5. From 3 to 5. So I have, okay, I need the bag. I will put 3 to 6. So that's how to index a list. I can loop through my list to check each item in the list. To do that, I will use a for statement for item in my list. Then print item. You can see that these are individual elements of the list, each element of the list. If let's assume that my list is just numerical characters, I can add them up, everything, my lists, numbers equals to 1, 2, 3, 4, 5. So I can say for number in my numbers. Number in numbers. I want to add up all the elements in this list. I will first define my sum as 0, the total of everything. Then for number in number, sum equals to sum plus number. So I'm saying that for each of the number in this list, my number, my initially my sum is 0. Then I'm saying that anything, the first element of the number should be added to my sum. For the first time the code runs, I will have sum, which is 0 plus 1. Then subsequent 1 plus 2. Then the sum, the new value for the sum will be 2. Then plus 3, the new value will be 5, and so on and so forth. Then I want to print sum. Now I want to see my sum. I want to see the final answer. Print sum. You can see this. 3 plus 4 is 9. Then 9, 12, 13, 14. Then plus 1. That's 15. So that's about Python list. Then we have a for loop and a while loop. I talked about for loop yesterday, where we used a range. For I in range, let's say 1 to 10. Then print I. For I in range 1 to 20, print I. What's the error? Invalid syntax. Okay, it should be comma, not colon. Therefore, 1 to 20. This is our 1 to 20. And we have while loop. While loop and for loop, the two of them, they are used for iterating over a data type, a collection of objects. But we use while loop mostly when we don't have an idea of how many items we are checking. Let's say my color. Okay, there are some things we can add to our for loop. We have the break. I talked about pass yesterday. Continue. Yeah, those are the three. The first one, let me declare a new list. Colors equals to, so you have red, black, green, yellow, white. So firstly, I can say for color in colors, print color. We have black, we have red, black, green, yellow, and stuff. The uses purpose of this break, these three statements, we use break when we want to break out of a loop. Or by default, this while loop, while one is greater than zero, then you say print one is greater. Then we have this. We know that this statement, while one is greater than zero, one is greater than zero, it will continue to run like forever. Just one is greater, one is greater, one is greater. If you come back tomorrow, the code will still be running. We can see it will still be running. You can see. You can see. You can check the progress here. Can we all see this bar? All this bar. Can we see this moving down?
Yeah.
So that means the program will continue to run
Yeah.
because the condition is
Yes,
we
sir.
always because the condition will always be true. So to stop this kind of, that's why we have these three keywords. So when we want the output to be printed just once, we use a break statement. If I don't stop this, it will continue
Okay.
printing till forever, till maybe my laptop die or anything happen. So I need to stop it. I need to interrupt it. I click here now.
Execution.
So I can now use a break statement, a break keyword to stop it. With this, it will be printed just once. Can you see the difference
Okay.
now?
Yes,
We
sir.
have it just once because it's I break the code already. So the pass, we use pass if we don't really need, we don't know what statement we need. For example, you don't know what you don't, maybe you are thinking about what to write if one is greater than zero, just write pass. Pass will just, nothing will happen. No, this is still running. One while one is greater than zero, pass. That pass simply means do nothing, don't do anything. That's the function of the pass. This one is just going and coming back. Let me use those keywords with the color. For color in color.
Okay, colors. So
If
colors
if
and
color
colors.
equals to red,
Okay. Pass.
if color equals to red, then break. Print color,
Break.
then break.
If if color equals to black.
Let me bring this red to somewhere around the middle. So I have my red here now. Let's take note of this indentation. For the first one, for every other thing here, from here to this place, every one of them, they are under the first statement. You can see this arrow. If I close this, everything will close, everything will collapse. Everything will collapse. But the other one here, this if, it is only these two statements that are under the if statement. If this condition is not true, these two, the remaining two lines, they will not run. So they depend on this particular line. You see now. So what I'm saying is, if for color in colors, I'm telling the code to check through this my list called colors. Then if you see any color that is equals to red, print the color, then break, stop. This is the first thing we have for color in the initial looping we have for color in color. Print color. So we have this. Let me run this again. We have the colors here, black, green, red, and yellow. So I want to check if I have, maybe I have like 10,000, thousands of color in my list. Then I want to check if I have green there. So what I need to do is for color in color, if color is equals to red, print that color, then stop, break, is it? Continue is used to skip. For color in color, if color is equals to red, then continue. Control X. So I want the colors to be printed. Then if the color is red, it should be skipped. Then print the other colors for me. You can see we have black, green, we still have red. So the print statement for color in, I want to make sure this red color is skipped. For color in colors, if color is for color in color, print colors. Then if color is equals to red, continue. Control X. What I want to do is to make sure this red color is skipped. I don't need it. First print color. Then if color also. I still have the red. For color in colors, print color. Then the first one will be printed black, green. Let me try and move this to the end of the line. This is, we can see that the red is not included now. So that's the function of the continue button. Continue keyword, it will skip the particular condition. When the call, it will loop through, check through all the colors and be printing it. For the first time, it will see this black, then it will check the condition. Is the color equals to red? No. Then this particular line will be skipped. Since the condition is false, then it will go to the next line, print color, it will print the black. For the second time, it will check green. Green is the color equals to green? No. If the condition is false, this line will be skipped, then go to the next line. Because this print statement, the last one, is not, it doesn't depend on this if, it only depends on this for. So it is on the same line as if, like they are, the two of them are acting independently. Then it will get to the red color. Okay, is color equals to red? Yes. Then this keyword will not be executed, which is skipped. Then it will not print the color again. Then go back to the loop, check the next color, yellow, then white. Then that's the function of these three keywords. The break to stop a loop, pass to write, like if you don't have anything to write in the statement, then continue to skip. That's the function of the three keywords that we talked about range yesterday. So we have tuple. Tuple is, oh, there are some list function. There are some method we can apply on lists, like we did for string by color dots colors dot append. We have append purple. Append is to add another color to it. So let's check the color now. Colors. We have purple. So purple has been appended to the list. Then we can remove colors. Dot remove. What do you want to remove? We want to remove green. Then let's check our color now. Colors. You can see that the green color is no more there. So another thing we can do is color.pop. Color.pop and color.remove, the two of them, they do the same thing. The only difference between them is this. Color.remove, it will remove a particular value from the list. Color.pop, by default, it will start from the last element in the list. Color.pop will remove the color with the last element, which is purple. You can see we don't have purple again. Then another thing we can do is to specify the index. Color.pop. I want to remove this. I want to remove yellow. This is 0, 1, 2. That's 2. Then I check my colors. You can see that the yellow has been removed from it. So those are and I can clear the list, the old list. Colors that's clear. So let me check the color now. It is telling me that I don't have any element in the list, but I still have the list. This is an empty list, nothing in it. But if I want to delete the whole list, I will just say del colors. It will delete the color. If I call it again, I won't see anything. Colors, nothing. It will give me an error that I've not declared it. So those are the methods we can apply on a list. So we have tuple. Tuple is a collection of elements, just like the list. The difference between tuple and list is that as we can change tuple, we can change list, we can append, we can remove, we can add. We cannot change a tuple. And we indicate a tuple by this parenthesis. My tuple equals to 23, 56, 90. And I can put false as well. I check my tuple. So this is, let me try to add something to it now. Dot add 56. Tuple object has no add attributes. Let me try the append. It has no append attribute. That means it cannot be modified. I cannot modify it. So that's the difference between tuple and list. There are some things I can do on tuple. I think I can remove from it. Okay, I can remove, let me remove 90. And check my tuple. Okay, remove also is not working. Basically, yeah, a tuple cannot be modified. Once you have the data type, you cannot modify it at all. You can't modify it at all. And one thing I forgot to mention, you can sort a list. For example, I have the color here. I can sort it in alphabetical order. Where did I declare the color? Okay, this is the color. Colors.sort. Initially, we have black, green, red, yellow, white. Then let me check my color now. Now I have black, green, red, white, yellow. This is alphabetical order. So those are the methods we can apply on lists. We can sort we can check the length of a list. That is how many elements we have in the list. The number of elements we have in the list. learn colors. So I have 5 elements in the list. So today we'll be checking something, making use of those things we've checked with lens. We talked about yesterday, the grant access and denied access. So today we'll be making use of those things to create, let's say, a grading system. If we will be combining if statement and some other things. For example, write a Python program that grades students according to their score. So if the score, the first thing you will ask the student, there's something in Python, inputs. We use it to collect inputs from users. Your score is equals to inputs. What is your score? So if score is greater than or equals to 70, print your grade is A. Okay, let me just use 50. Okay, if score is greater than or equals to 17, print your grade is A. Elif score is greater than or equals to 50, print your grade is B. Else will always be the last. Print your grade is F. What we want is we want a grading system that anything from 70 to 100 will be graded as A. Then from 50 to 69 will be graded as B. Anything lesser than 50 will be graded as F. Let's check what we have here. Inputs, please. What is your score? Let me enter 78. So it's even giving me an error. What's the error? Greater than or equals to not supported between instances of string and integer. So this is what is happening. By default, anything that is entered through the inputs function. Inputs. Okay, let me copy this line. Control V. And I call it score. And I want to check the data type of my score. Type score. My score is 56. And you can see here that the data type of what I just entered is string. By default, this input function, it takes in string data type. So I need to convert it to integer first before I can perform this greater than equals to operation on it. So to do that, I just create a new variable equals to anything that is entered here as score. I want it to be converted to an integer. Score. So since Python runs from top to bottom, the first one will be saved as an integer, as a string. Then the next one will be converted to an integer. So let's try to run the code again now. 78. Your grade is A. Let's try with another score. 58. Your grade is B. Then let's try 49. Your grade is F. Are we okay with that? Hello, do we understand the whole process?
Yes.
So the first time we asked the student, the user, to input a score. Then we converted the score to an integer value, integer data type. Then we check with the if statement a condition that if the score is greater than or equals to 70, tell the student that your grade is A. Elif is else if. This elif must always be in between if and else. So we can have as many elif statements as possible. For example, we have a grading system whereby we have 70 to 100 as A, 60 to 69 as B, 50 to 59 as C, then 40 to 40, 45 to 49 as D, 40 to 44 as E, then anything lesser than 40. Anything lesser than 40 as F. So we can, all those between them, we will put in else. For the first one, 70 and above, we use if. Then 60, 69, elif, 50, 59, elif, 45, 49, elif, 40, 44, elif. Then the last one, we make use of else statement for that. We make use of else statement for that. So another data type after the list is we have the list, the tuple, and then the set. My sets. So for sets, we make use of curly brackets. We should try to note the difference between the three. The first one, list, we make use of square bracket. The second one, tuple, we make use of parentheses. Then the last one, set, we make use of curly brackets. Use curly brackets. Sets, it can be for tuple, we can index tuple, like we need the first element of our tuple, we need the second element, we need the last element, then we can slice like from the third to the fourth, from the third to the last. For sets, the difference between set and the others is that, for example, in our color, we can have in our list, we can have as many red as possible. And say everything can even be red. It's equals to red, and you have 2, 3, 2, 5, 67, 1, 1, 1. Then let me check the list. I can see that I still have all the one that I repeated, I still have them repeated two times, 1 4 times. The same thing for tuple. Control X. So I want to check my tuple now. I still have all those values repeated. Red, 2, 2, 1, 1. I still have them. But the set, it takes unique value. Even if I declare it with many values, it only takes unique ones. It doesn't take repeated values. My sets equals to set. Do you see this? I have 2 red. When I declared the set, I said there are 2 red. But when I check it, I have only 1. The same thing with 2. I have 2 2 times, but I'm seeing it once here. Then I have 1 4 times. I'm seeing it just once here. So the difference between the 3 of them, list can be indexed, can be changed, and it is not ordered. Like it's not ordered at all. For example, normally my ones should come before 2, before any other thing. It's not ordered. And I can add to it, I can remove from it. But tuple also is not ordered. I cannot add, I cannot remove from it, cannot be changed. Then my set is ordered, then it only contains unique values. Like it doesn't contain duplicate values. Those are the differences between the 3 of them. This one is not ordered, I can modify it. This one is not ordered, I cannot modify it. The last one, set, is ordered, then it doesn't take duplicate values, then I can also modify these two. So let's try to index my sets 0. I can't even slash it. So I need to call them by their name. My set 1. Do I have that? No. So I cannot also call it anyhow.
I think you are using square brackets.
Oh, I'm supposed to use parentheses. Yeah, square brackets is for indexing actually.
Okay.
Square brackets is for indexing.
Set and order, so you can't index it.
Yes, that's true. Another thing we can do with our list, we can check if there is actually a particular value in it. Let's check with the color. Red. We want to check if we have red in our color. Red in color. You can see it returns true. That means we have the red color in our color. And we should note that Python is a case-sensitive programming language. This red is different from the lowercase red. Red. This will give false. Then everything in caps are reading. So we can use this one to check. For example, let's say I have a list of students. I have Bola. Then I want to check if the student is in the list. For example, I can use this one as a kind of attendance. Okay. Name equals to what is your name? Inputs, what is your name? Then I will check the name. If name in students, that's the name of my student list. Then print absent, present, else, print absent. So name is checking through the list. What is your name? I input Fola, then absent. What is your name? I input Bola, present. What is your? I'm going to input Kemi now. Everything in lowercase. Kemi, absent. Whereas I have Kemi here, so that's a kind of issue. So to try to rectify this, since I have my name, the student name, they are in title case. So one thing that can help this program not to like some people that's present, so that the program will not be marking them as absent. what I can do is try to convert anything they give me. Since I have their list in title case, anything the student inputs, I should try to convert it to title case. Name equals to name dot title. Name dot title. So this one is expecting any kind of answer from the student. Let's say the student decides to do something unusual. To capital D, capital D, capital E, capital T, capital D. Then I press enter. You see present. Then Kemi. If you like, write your Kemi, everything in uppercase. You are present. If you like, write this uppercase, lowercase, uppercase, lowercase. La. You can see it is still marked as present. So this is very good to take note of different input from the users. You expect students to enter anything they want anyhow. For example, someone mistakenly press the caps lock on the system, then instead of typing small letter B, the person mistakenly typed, let's say, capital letter B. So this particular line, we take note of that. We can check what our name variable is. Print name. Kemi. So Kemi is entered, but everything is converted into title case, starting with the capital letter. So I think this is a good place to stop. Actually, we still have time. Do you have question? Let me quickly go over it in a few minutes. So I talked about the logical operators here, where we have the and or not. And if we expect a true output, both conditions or all the conditions present must be true. Then if you are expecting a false output, just one of the conditions has to be true, just one of them. Then for all, just one of them has to be true. But for and, all the conditions must be true. That's why we have true and true, true. Others, since not all of them are true, we have false, false, false. Then or, we only need one of the conditions to be true. We have true, true, true. Then the last one, none of the conditions is true. Then that's why we have false. Not please, just like the opposite. Not good, bad. Not okay, not sit, stand. Not going, stop. Those kind, like the inverse of it, the opposite of it. That's the logic behind the logical operator. Then we have the looping through the list. This is the list, the indexing list, negative index, then slicing from something from like a particular range, then looping through the element of a list, then summing up a list. We have the element of a list. These are 1 to 15.
I have
Then
a
we sum.
question.
What's the question?
You use sum as
Yes.
a variable name. Is that the right practice?
Is that
Sum is a keyword in Python.
yes? Let's try that. Sum 3, 4. I think it sums. What does it do? So convert the number of string to an integer, return if no argument is given. Maybe it's because I declared it already. But normally you shouldn't
Okay.
use a keyword as your variable name. Normal on other normal circumstances, you shouldn't use a keyword as a variable name. You can call it add up or any other thing. Add up. And we change every other thing. But if using sum, I've seen some many examples with sum. So you can still make use of it, but under normal circumstances, so that you don't have issue a lot. For example, if you use type equals to 78 and 98, you can have your code very okay. Then if you want to check the type of a variable, you might have problem. Then type color. You see the problem now. Whereas I can use, normally I should be able to use the type to check the type of the data type I have as my color. For example, this is my list. Let me run this line. Then check the type of my list. Type my list. It's because I've declared type as 89. So all I have to do is to just restart all this, restart runtime and run everything. So I need to comment out this line so that it doesn't run again. That's why you should be careful using keywords. There are some you can, the system will not even allow you to use them, but there are some you can find your way around it. So this is where we were. Type of my list. You can see that it's telling us that it's a list data type. But once before, when I assigned this 89 to the type variable, I couldn't get the data type here. So that's why you should be careful not to use keyword as a variable name. There are some of them, the Python language will not even allow. For example, you want to use or equals to 89, like this one, it won't be possible at all. You can see. But there are some, if you find your way, you might have problem along the line when you are trying to do some other things. Do we have any other question?
Yes. Actually, I have a question, but I think it's down.
Okay.
Yeah, not here. No. I think it was on tuple when you create a tuple and there was a member of that tuple that happened to be a string, and sorry, yes, it was a string, and it was not in quote.
Are you sure?
Yes.
Okay. Where do you have the tuple? Okay, this is tuple. Okay, you are talking about the false, right?
Exactly.
No, this is not a string. It's a Boolean data type. Boolean.
Now I get it. Now I get it.
Get. Okay.
Yeah, I get it now.
Any other question?
Yeah,
When
I have a
talking about
question.
Okay.
Yeah, the differences between the parentheses and the square brackets, I didn't really get it.
Okay. This is parentheses. The normal one we call brackets. Then we have the square brackets. This one. Then we have the curly brackets. This one. We use this parentheses to declare a tuple data type. We use the next one, square brackets, to define a list. Then we use this last one to define a set.
okay, sir.
Do you need
Can you go
example?
to where
Yes, I would appreciate if you can give an example.
This I can use the same element. Let's say A also. 1, 2, 3, 4, 5. And I want to check the data type of A. Type A. We can see that's a list.
Okay.
Then I'll have my B. You can see that's a tuple.
Okay. Yeah.
Then the last one. C. And see the data type set. So
Yeah.
that's the difference between the three of them. And another thing you can do if you want to like to cast an element into a list, instead of using this particular bracket, you can type the name straight. For example, A equals to list. Then you have it in brackets 1, 2, 3. Then you check the data type. Type A. Okay, for casting, you can do casting. For example, we have this tuple as we have our B as tuple already. Let's check B. This B. If you want to cast it to list, just type A equals to list, then B. Let's now check the data type of A now. List. Then let's check the data type of B. Type B. We have B as tuple, we have A as list. That means we casted our tuple into list. We can do that for set as well. If you want it to be in as a set, you just write set. And we check the data type of B. Data type of A is set, then our B will still be tuple as it was before. Is that okay?
Yes, yes.
Yeah.
Thank
So
you.
where you are explaining about grading.
You said what?
You are explaining about the grading stuff.
About the
Where you are using grading. You are saying
grading, okay?
if elif and effects.
Okay, this is the part.
Okay. You are explaining something about elif. If you have, see that if you have B, C, D, you can use
If you
elif
have
for B, C.
if you have
That
many
is something.
conditions to include in your code, you have, let's say, more than normal is the default, like the starting point is to have one. If then you can make it two. When you are talking about two conditions, you use if and else, the first one and the last one. When you have three and above, that's when you make use of elif. When you have more than three conditions, this is the first condition, this is the second condition, then the last condition,
Okay.
else. So there are times maybe your grading system have maybe, like, let's say 5 different grading points. Then you can use 3 elif, then 1 if, the last one else.
All right. Thank you, sir.
You're welcome. In the absence of no question, we can. Okay.